Hi, this is Synthchaser from Synthchaser.com, and I'm wrapping up an overhaul on this ARP Omni 2, and the only problem that's left with it is some noise in the output, but only when I have the strings engaged. So here's strings, and you can hear there's quite a bit of noise in the output there. And if I put on the synthesizer section, the polysynth, there's no noise in the output. So that gives us some information to narrow this down, and I'm going to show you how to track down noise in your output like this. So there's a nice little block diagram here that shows us how the ARP Omni 2 works. And what we're going to do is we're going to take a look at the first point that the circuit deviates between string and synth, and that would be here where it switches these instruments on and off. So that's done by a CD4016 chip, and they tend to fail a lot. So we're going to go and poke this inputs and the outputs of these switches and see if the noise is being introduced here at the switches. The tool that I'm using to track down the noise is the oscilloscope, and for this type of problem there's really no getting around using an oscilloscope. So we're going to probe the analog switch. So this is the wave coming into the analog switch, the 4016, and pin 2 is going out of it. And it looks the same. The oscilloscope's triggering fine. There's no noise or which would show up on the oscilloscope as like random waveforms in the output. So it looks like the analog switch is okay. Now we'll get the block diagram and see where to look next. So coming through this switch, the next thing it goes into is the phaser. The phaser is also used for the chorus effect on the synthesizer, which we didn't test out, but we could do that in a moment. And the next thing is the string VCA. So maybe let's look at the input to the string VCA and see if we have noise here, and then we'll narrow it down to either the phaser or the string VCA or the output stage of the string VCA. Okay, so the ARP Omni 2 has its string VCA located here on the synthesizer control board. And then there's a cable that takes it down, this ribbon cable takes it down here to this bass board, it's what it's called, which kind of does a final output VCA stage and then puts it out on the jack. So let's check the output of the regular string VCA to the string output VCA. So we're going to look here on pin 14 of this connector. So I'm pressing a note, and I'll turn the volume up so you can hear. You can see the pattern is irregular. Because there's noise in the output. So the problem is not down here on this output stage. The problem is at least it's after this analog switch, but before here. So it's either in the string VCA or the phaser board. So now let's look at the input to the string VCA, and that's coming from the chorus phaser board. And the connector comes out here and kind of goes under there, so it's going to be hard to get to, but I can just poke it here on the phaser board. So this pin 6 is the output of the phaser and the input to the string VCA. And you can see I've got no signal going through there, and I've got this random noise here in the output. If I press a note, you can see the signal kind of getting dwarfed by the noise there. So the problem looks to be ahead of the string VCA, and it's somewhere here on this chorus phaser board. So let's look into that a little closer. This is the schematic to the phaser board, and for reference we were poking right here on pin 6 of this connector, which is the final output of the phaser. So let's now turn our attention to the input. We'll poke the input, which is on pin 5. But basically the input comes in and it goes to this op amp. So when you have an op amp connected this way, where you have the inverting input, the little negative symbol connected to the output with nothing in between, no resistor or anything like that. That op amp is configured as a buffer. So basically it's allowing this phaser and everything that comes after it to do its stuff to this signal without putting any load or affecting the input signal in any way. So let's take a look here at the input, and then let's poke around this op amp here. So first let's confirm the input to this phaser board is good and not noisy. So pin 6 was the output, that's where we were seeing this noise. Now let's look at the input. So the input is pretty flat, so there's no noise on the input here. Now let's take a look at the buffering op amp. So the output of that is on pin 1. So let's probe pin 1 of this, and would you look at that? We have noise on this op amp that buffers our input signal. And to give you an idea of the magnitude of the noise, I'll press a key. So it's a pretty significant amount of noise relative to the signal strength. So most likely this op amp is bad. I mean, it didn't completely fail, but it's introducing noise to the signal. If it's not, then we can take a look at some of the passive components, the resistors and capacitors in the circuit around this. But for starters, let's pull this op amp and replace it and see if that fixes our noise. So here's that section of the board, and I saw kind of hiding behind this capacitor. There's a diode there in the circuit that's connected to the output of this op amp, and diodes can also get noisy. They're a semiconductor device, and they can get noisy. So while I'm pulling out the op amp, I'm also going to pull out this diode and replace it as well. So I've changed the little diode hiding back here, and I've changed the op amp, and we still have our noise in our output. So we know that it wasn't coming in here on the input signal. So on the input signal, we're getting a nice clean signal there. So it has to be caused by one of these passive components, like a capacitor or a resistor nearby. And we can confirm this by pulling the op amp out completely. I know the circuit's powered and everything, but it's not going to hurt it. I mean, it kills the output to the synthesizer. But basically now we're going to go from this input signal to the non-inverting input of the op amp, which is no longer there. But we're now confident that the op amp and the diode won't be affecting what we see on that pin. So that was pin 3, and you can see that there's noise there. There's my signal with the noise. But the noise is there without the op amp, and with the op amp removed, then the diode is out of circuit too. So we're going to have to take a look at what's going on around this area. So I wound up replacing all these passive components here ahead of the op amp, since with the op amp removed we were seeing the noise here on pin 3 coming into the op amp, and we weren't seeing it here coming into the phaser board. So I replaced the capacitor and then these two resistors. And the resistors that were on the board, they weren't these 1% precision resistors. They were regular 5% tolerance carbon comp resistors. So I changed those, and I changed the capacitor, and I still had no effect. I was still getting the noise. And I was taking a look around, and there's a trimmer up here that wasn't on the schematic, and it was connected to this pin 3 of the op amp. So I guess instead of using precision resistors, they put a trimmer in there that you could adjust. So it wasn't on the schematic, but I noticed it was connected ahead of this op amp. So I changed it. The trimmer that was there looked like garbage. I mean, it's this open frame type of trimmer, and if I had realized that was there ahead of the op amp, that would have been the first thing I suspected after the op amp and the diode. So I changed that with a nice multi-turn trimmer, and now let's check out the output. So now the strings are nice and quiet. No noise coming from that phaser. So our problem turned out to be a bad trimmer that was causing this noise in the output. Hopefully this video gave you some helpful hints on how you can track down noise coming from an instrument. We use the block diagram and the schematic, and use the oscilloscope to narrow down on the source of our noise, and then pretty much exhausted all possibilities in that area until we found the culprit, which was a trimmer that wasn't even listed on the schematic. The method that I showed you can use to find noise coming from other areas of your ARP Omni 2 or any other vintage synth for that matter. So this ARP Omni 2 is ready to get calibrated and find a new home. It'll be for sale on my website pretty soon. This has been the Synthchaser from synthchaser.com. Thanks for watching and have a great day.